operating system. In today's session, we are going to discuss the concept of deadlock, which is very important with respect to operating system. Myself, your instructor. In today's session, we are going to discuss the concept of deadlock with real-life situation as well as deadlock with respect to operating system as well. So before going to discuss deadlock with respect to operating system, let us discuss first deadlock in real-life situation. So deadlock is one type of problem that can occur in real-life situation as well as it can occur in operating system as well. So what is deadlock? So let us concentrate on this particular figure in which the road traffic scenario I have taken to understand the concept of deadlock. So in this particular scenario, there are different roads we have, and this is nothing but pre-planned road that we have in this case, and vehicles are moving into different directions, starting from, we can say, top to bottom, then left to right, then bottom to top, and then right to left. So in these particular directions, the vehicles are moving. So you can see there are a number of vehicles and they are moving in different directions. So what is deadlock with respect to this particular situation? Means in operating system, the resources are finite, okay, and processes are, we can say, unlimited. So if n number of processes are trying to access a limited number of resources at the same moment of time, in that case problem may occur. So what is the problem? Let us discuss with this road traffic scenario. So we can concentrate. There are 4 junctions we have, or we can say 4 chalks on these junctions we have in this particular scenario, in which the vehicles are blocked. How? Means you can concentrate on the vehicles traveling from top to bottom. That top to bottom vehicles are blocked with the vehicles which are traveling from left to right. Same way, left to right vehicle are blocked with the vehicles which are traveling from bottom to top, and at the same way, in the case of 4th scenario, the vehicles from bottom to top are blocked with the vehicles which are traveling from right to left, and these right to left vehicles are blocked with the vehicles which are traveling from top to bottom. Means if such type of situation occur, none of the vehicles can move ahead. Yes, so this situation is nothing but a deadlock. So this is the real life situation. One of the example of deadlock in real life situation. I can give one more example of deadlock with respect to real life situation. Let us suppose if we have 2 friends, and 2 friends are, let us A and B are friends, and A and B person are going to a particular function, and they are trying to get a soup from a soup counter, and once they reach to the soup counter, only one bowl and only one spoon is left. So what will happen in this case? The person A will get the bowl and person B will get the spoon. Now what will be the problem in this case? any one of these wants to have soup, so that person requires not only bowl but also requires spoon to get that stuff. But right now, both of them have different, one of them, contains in a bowl and one of them, have spoon. So if anyone wants to acquire a soup, it requires both the resources, but that resources are not available at that time. Means person A is waiting for person B to release that resource, and same way person B is waiting for person A to release the resource. Yes. So again, this is nothing but a deadlock situation. Means what? None of them can get that soup at the end if both are waiting for each other. Yes. So this is another example of deadlock. Now let us discuss deadlock with respect to operating system. So what is deadlock? In multi-programming operating system that we have discussed in the previous session in detail. So in multi-programming operating system, there are pool of processes that processes are waiting for execution in the CPU. A number of processes, as I told you, in multi-programming operating system, number of processes competes for a limited number of resources. And if a resource is not available at that instance, then the process enter into a waiting state. That is possible because we have a number of processes. Number of processes cannot be, we can say limited. It can be, infinite number of processes we have. But we have limited number of resources. So it is a finite number of resources we have. And if that set of processes requires a finite number of resources at the same amount of time, definitely some of them needs to wait for others to release that resource for its execution. Yes, so that can be possible. So some of the process may enter into a waiting state. What is waiting state? That we have discussed in the process state diagram. Process may execute in the CPU, or process may in waiting state when it requires no IO devices for its operation. Yes, so there some of the processes are waiting. Now, if a process is unable to change its waiting state indefinitely, yes, now we are moving towards the perfect definition of we can say deadlock. So if we have more than one processes and some of the processes are waiting to get the resources, and if that wait is indefinite because the resource which is requested by that process is held by some another waiting process, that the system said to be in a deadlock. Means suppose if I am looking for one resource, say for example printer. Yes, okay. So a printer is, we can say, non-sellable device. At a time only one task can be completed by the printer. So when I send a request to a printer, at that time there are chances some other user is using the services of printer. That is possible. So what will happen? I need to wait for a certain amount of time to get my chance to use the printer print services. Yes, so I need to wait for some time. But what will happen if this wait is infinite? Because printer is executing some another process. In that case, after some time it will be free and I will have a chance to access that printer. But what will happen if printer is in a waiting state and that printer looking for some another resources for its own execution, and that resource is acquired by me? So what will happen? Means both the processes are waiting for each other to release the resources, and this situation leads to a deadlock. Okay, so this is a nothing but definition of deadlock. Now we can understand the concept of deadlock clearly with respect to operating system with the help of resource allocation graph. So you can see in this particular figure, this figure is nothing but resource allocation graph. In this particular graph, there are two circles. The circles represents processes and square box represents, or as a rectangle represents what? Resources. So P1 and P2, are nothing but processes, and R1 and R2 are nothing but resources. Okay, so what will happen in this case, and what this arrow suggests us? So the arrow which starting from process towards resource, that is nothing but a requesting edge, and the arrow which is starting from resource towards process, that is nothing but kindling edge, or we can say holding edge. Yes, that is a requesting edge, means what? In this case P1 requesting R2 resources for its own execution, and P2 is requesting R1 resource for its own execution. Same way, as far as holding edge is concerned, so right now P1 holds R1 and P2 holds R2. So in this particular scenario, P1 and P2 requires R1 and R2 both resources for its own execution. But what will happen? P1 acquired R1, but P1 require R2 for its own execution, but R2 is already acquired by P2 right now. Same way, P2 requires R1 and R2 for its own execution, but P2 acquired R2, but P2 requesting R1, but R1 is already occupied by P1 right now. So it means there is one cycle. Is formed, and this cycle is nothing but if such type of cycle exists in this case, in that case we can say that the deadlock is occurred. Okay. So this is nothing but, this graph is known as resource allocation graph, in which it contains set of edges, then processes and resources. Okay, so with the help of this figure, you can easily understand what is the concept of deadlock with respect to operating system. Okay, now in operating system, a process utilizes the resources in the following sequences. Okay, if any process utilize or use the resources, so that process needs to follow this sequence of steps anyhow. Yes. What is the first step? So if any process requires resources, so first that process will send a request to access that resource. And if resource is free at that point of time, then and then that request will be granted, okay, to that process. And once it is granted, now then that process can use that resource, and once it uses that resource, then the process needs to release that resource so that other process can use that resources for its execution. So this is nothing but a system model that every process has to follow with respect to deadlock in operating system. So in this particular session, we understood the real life example of deadlock with respect to operating system. Okay, and we elaborate the concept of deadlock with respect to resource allocation graph. So I hope it was clear to you. Thanks for watching this video.